Hello everybody, this is Pete from PA Labs, and I'm starting out this video on the PureBasic forums page because the work I've done here recently is kind of related to this post. So this is a post, and it was put out there about using hexagons, and specifically this graphic right here that I'm showing you. What I would love to do, what I would love to lay my hands on this source code for this little demo right here. This is really spectacular. I really give him points. And so I decided that, this whole pathing thing is something that needs to get done. And it's something that I've kind of set out and seriously attacked. And the source of all of this is there's YouTube videos. The hexagons are the bestagons. That was a very cute video. And then, of course, the Red Blob Games. Now, the Red Blob Games, I've been at their site and I've mentioned it numerous times. And this is probably the source of authentication and math to do with hexagons that I am aware of. It's probably the pinnacle of it all. And this is quite an impressive site. And he does the math about 3 different ways, and he's got all kinds of stuff out here. Now, what I want to point out is in my war game and in the map maker software that is behind it, I support the Pointy top grid here, which is a odd R variant of the horizontal layout. And basically, I call this a vertical grid because the 2 sides are vertical and you can go sideways without having to change direction or you go just straight sideways. And then I also support the even Q, which actually Q is his reference to column, and that's in the math equations and whatnot. So we have the flat topped even Q variant, and we have the odd R variant that are out here. Now, he does really most of his math, and the foundation for the vast majority of his mathematics is based upon the 3D cube version of a hexagon. And if you study that cube good enough, or maybe you stand back far enough and cross your eyes, you'll see it as a hexagon, and that's where the root of all the math that he does comes from. And there's a number of functions that actually you have to convert between the what he calls axial coordinates, which are the XY 2-dimensional, like these 4 grids here have, and the cube dimensional, which has the X, Y, and Z planes, okay? Now, if you come out here and do some studying, his reference and his formulas come back to Q being column, R being row, and eventually he comes in with S, as in Sam, being the Z coordinate, okay? So, and there's a lot of good stuff here. This is pretty impressive stuff, actually. This is where I got the mathematics to do the movement on the grid and stuff like that. And so you actually have in the source code that I've passed out already and in the game itself, you'll see a lot of these functions, though they very well will be renamed. What I've really on the outset of this project here, I'm going to be showing you in a minute, was to do the pathing. And I'm scrolling down here to get to it. Let's see. And this is pretty much, well, this is a biggie of it right here. Being able to draw a line and actually find the hexes and not have it jump or skip a hex to get this working. This is the root of everything that you have when we go back and look over here. When you're looking at this is just adding in blocked hexes and that sort of thing. But the root of it is this guy right here. So how do you do this? That was my battle, and I kept running into trouble. Let's see, I'll get down here. And this is literally what that code out there is trying to do. And sadly, he really doesn't come in and tell you how to do this exactly. He gives you bits and pieces and you got to figure it out. And I guess that's probably, the good way to do it, make people learn. Um, and so that's kind of what I'm going to try to do here in the next this video and the next, and with this project I've done. Now, the reachable hex, this is the root of this guy here, where he's got blocked hexes and he's trying to find a path. So this is the root of my movement in the game, where he comes back. This is the flood fill calculation that loads in all the hexes that you can reach within a certain movement. And by putting in a few more ifs and blocks and keeping track of how many movement points you've used and stuff like that, you can come back to this. But then drawing that line, now that's a different creature altogether. And I've spent 2 days, solid days, working on this. And so I've done the math up to here in both cube and in axial coordinates. And matter of fact, I even built this breadth first search. I took apart the web page here and got to the source on the web page and started playing with that as well. And so he has a number of caveats. If we come back to this guy here, most of the math you're going to play with comes out of here. And he's got some examples of problems that he has. And I've read and reread this numerous times. And so it really starts out with this one sentence. How do we draw the line from one hex to another? And he's using a linear interpolation for line drawing. So hitting that link brings us to another whole slew of calculations. Okay, starting from an endpoint and from one endpoint to another endpoint, and trying to track the in between. So this is where that comes from, is in here. And I have faithfully recreated all of these functions, and then ran into some trouble and had to work out a few pieces on my own, because this is all written in a mixture of Python and JavaScript and stuff like that. And so let me come show you what I have built. So this is just, I call this grid play. And so we start out with just a flat screen, and you have the vertical hex. So this is the going sideways is a straight line, not vertical. So the other name that we have for this is the pointy top hex. And then you also have the horizontal grid that it can build where you can go up and down, but you can't go sideways in a straight line. Okay. And you got the diagonals. So the goal was to be able to select a hex and then go anywhere in your field of view and track the center of the hexes in movement to go from one point to another point. So with that still selected, I can do these beautiful little straight lines all day long. That's pretty nice. They're not skipping. They're not jumping from here to here. They're just really walking the grid itself. And there's a few tricks to this. And what we're going to do if we go sideways, he actually walks the whole grid for you. So you can go to any square and you can just line it up and see what the path might be to get there. Okay. Now, the trick in this whole thing was to be able to not only do it with the flat topped hexes that I've done most of the work in, but also in the vertical grid to be able to select a hex and go wherever we might need to go in this realm as well. Okay. So without changing the code. Now see how he did this right here? This happens because of the number of dots and whatnot. And what we have to do is, as the formula, the red website there makes the comment, you have to kind of nudge it a little in a direction, and then be able to deal with it. So what you see over here on the web page here is these are teensy little hexagons. And I think that would make matters a lot easier if we were using like a little itty bitty pathing grid. So, but we're not. We're using this great big monster grid of 64 by 64. So how do you nudge the calculation, you know? And if you think about it, if you looked at this grid, you have, if we go vertical, each of those dots are actually 64 pixels apart, right? Because that's a 64 by 64 hex. Now, if we go down the diagonal, we're at 64, 64. But if I go here, where he has to come up and then over, well, those two dots aren't 64 by 64 apart. They are from the directional standpoint, but if you take the beginning point and the ending point, then there has to be something that nudges it to the left or to the right for it to go, I got to go to this hex and then here. And so that's what the reference here of nudging is. When you actually call up this list of equations over here, where you're trying to draw a line from point 1 to point 2, and you've got a source and a destination. How do you split that line up to where, and there's a lot of math that's going to come into this. Ideally, I want to do it based on the slope of the line, because when this goes 90 degrees, when this goes sideways, we are at that is a 48 apart. If you looked at it from a straight line, the straight line has to be broken by 48, because that's 48 pixels and that the hexes are spaced off. Whereas on these straight lines, they're 64. So between the 48 and 64 splitting, and between this 64 and that 64, you're going to vary between 48 down the middle and then you're going to actually go up to 64 and then up to 64 in all of the ordinal directions. Okay, so calculating based on slope of line and doing a variance on the, what is that, 16 pixels that separates 48 from 64 is what I think is ideally going to give us the division that we need. So okay, so this video is going on a bit long. I'm going to break it into another video. So thanks for watching, and the second half will be out shortly.